Okay, so a couple years back, AP decided to throw in something new to the curriculum, and it's this rule called L'Hôpital's rule. L'Hôpital is French. I'm really disappointed because this is the modern spelling of L'Hôpital, but L'Hôpital, if you look him up, this is how he spelled his name with this silent S, L'Hôpital, so it looks like El Hospital. I like to write it like this because it helps me remember how to spell it. But if you look up the spelling, both are accepted. This new one is the modern spelling because, you know, we just change things to how they sound in English. But it does add this little thing at the top. And so both are accepted. It's up to you. But L'Hôpital allows us to take limits in a whole new way, and you're going to be so excited to take limits now. So it says, on the onset of our study of derivatives, we used to use the definition of derivative as a limit, right? So hopefully you kind of remember this as a derivative. It says, in the same sense, L'Hôpital's rule uses derivatives to find limits of certain functions, particularly those that are in indeterminate form. So remember that indeterminate form is when you get 0 over 0 or any term of infinity over infinity. Usually that means there's a way to simplify it so that there actually is a limit to take. So, little throwback here, when we first did limits, we would look at this, and you can plug 3 in there and get 9 times 2 is 18 minus 3 minus 15 over 9 minus 3 minus 6, and we get 0 over 0. And usually that means that there's a way to simplify it. So earlier in the year, first semester, we said, okay, maybe I can factor it to simplify it. So if I was going to do this limit as x approaches 3, the bottom's the easiest to factor because there's no number in front. Well, multiplies to give me 6. That subtracts to give me negative 1. The goal is to get this x minus 3 to cancel out, which means I'm going to use that I know there should be an x minus 3 on the top. So how could I get 2x squared? That means this would have to be a 2x. And how could I get a 15 if I know this is 3? This is going to have to be a 5. And they have to be different signs. And so you could do factor by grouping, but not really the important part of this lesson, so I'm just skipping ahead here. That if we could cancel this out, we could then do direct substitution and do 6 plus 5 over 3 plus 2, which gives me a limit value of 11/5. Right? Well, L'Hôpital changes the game for indeterminate form. So let's write out the definition of L'Hôpital's rule and see what you think. So it says, if the limit as x approaches a of f of x over g of x equals 0 over 0, or the limit as x approaches a of f of x divided by g of x equals any form of the infinities over infinity, then the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x divided by g prime of x. This is kind of a big deal. This is not using a form to find the derivative. It's just taking the derivative of the numerator over the derivative of the denominator. But the if part, just like all of our rules and theorems, you have to show that it's indeterminate first. It doesn't work if it's not indeterminate form. But if it's indeterminate form, then you can do this and you get the same answer. So we already did this one. This is the same one up there. We already know that we got 0 over 0. So I can use L'Hôpital's rule, and I can say the limit as x approaches 3 is going to equal to the derivative of the top, which is just 4x minus 1, over the derivative of the bottom, which is 2x minus 1, and then I can do direct substitution, and I would get 12 minus 1 over 6 minus 1. Oh my gosh, I still get 11/5. So that's what we're going to practice here. It's pretty life-changing here that we can do this. So we're just going to practice a few of these until my video gets too long, and then we'll finish the rest in class. So 2 other limits that we learned earlier this year were the sine and the cosine ones that we just had to try to memorize. But now we can show that L'Hôpital's rule does apply. So you always want to check that first. If you plug 0 in there, sine of 0 is 0. and 0 on the bottom, so L'Hopital applies. Make sure you rewrite your limit part, okay, especially on a free response. So now the derivative of sine is cosine, and the derivative of x is just 1. So cosine of 0 is just 1, right? So that's what we got here. It was just 1. What about this one? Again, if I plug 0 in there right now, cosine of 0 is 1. So I get 0 over 0. So L'Hopital applies. And the derivative of cosine is negative sine, so that negative becomes positive sine of x, right? The derivative of 1 is 0, and sine of 0 is 0. So once you know L'Hopital, you can do these. And you might say, well, why in the world didn't you tell me this at first? When we first learned limits, we didn't know all the derivative rules, and so we couldn't do L'Hopital's rule at the time that we did that. But now when you see a limit, you can check to see if L'Hopital applies, and it really is a game changer in terms of doing these problems. So let's get a little bit more complicated here, I guess. You do want to check, if it was a free response question, not only do you have to check that it's 0 over 0, but you have to say, like, just like mean value theorem, like that L'Hopital applies. Since it's 0 over 0, L'Hopital applies. These boxes aren't big enough, so I'm not going to do that in all of these. But I do check every time because they could give you one. If it's not 0 over 0, L'Hopital doesn't apply. But pi halves, cosine is x, and at pi halves, cosine does equal 0, and pi halves minus pi halves is 0. So I can take the limit here as x approaches pi halves, and the derivative of negative cosine would be positive sine, and the derivative of x is 1. Pi halves is just a number. And then when I plug pi halves in there, the limit value is just what is the sine of pi halves, and the sine of pi halves is 1. What about the next one? If I plug 0 in there, sine of 0 is 0. 0 plus 0. Like, I definitely still get 0 over 0. So it does apply. And I get to practice my derivatives. 7 minus cosine of x. And on the bottom, my derivative would be 2x plus, this is the chain rule, so it would be cosine, leave the 3x alone, but then times 3. And I always put the 3 in front, so that way I don't get confused by plugging it in. Now when I plug 0 in there, cosine of 0 is 1, of 0 plus cosine of 0 is still 1 times 3. So I get 6 over 3, which is 2. Not going to lie, I kind of like doing L'Hopital's rule. What about the next one? If I plug 0 in here, this is time, so 0. And on the bottom, sine of 0 is still 0. So when I take the derivative of this now, though, that's the product rule, so be really careful. So the derivative of sine is cosine, leave the cosine alone, plus leave the sine alone, and the derivative of cosine is negative sine. On the bottom, the derivative of x is 1, and then this is going to be 2 cosine of 2x with my chain rule here. We got to know our derivative rules. So now when I plug 0 in there, cosine of 0 is 1, so that's just 1 times 1. Sine of 0 is 0, and cosine of 0 is still 1, so I just get 1 over 3, I think, as my answer. Imagine doing that without L'Hopital's rule, right? Like, there's no way to simplify that with factoring, and so this allows us to do a lot more. Okay, maybe the last one. L'Hopital's rule can be applied more than once to the same problem, so just because you get 0 over 0 after you do it, it just means you can do it again. So like on this one, if you plug 0 in first, we get 2 minus 2 over 1 minus 1. So L'Hopital applies. So then I can say the limit as x approaches 0 of negative 2 times the sine of x minus, plus, because the derivative of cosine is sine of 2x, but then when I multiply the 2 in the front, that becomes plus 4. And then the derivative of the bottom is just sine of x. But look what happens when I plug 0 in there now. I get sine of 0 is 0 plus 0. So I still get 0 over 0. So what does that mean? It means that L'Hopital's rule applies again. I can't even spell. L'Hopital. Hospital. So I can do it again, over and over again, until I get to a function that I can actually take the derivative of. So now, if I take the derivative of this, it becomes negative 2 cosine of x plus 8, because the derivative of 2x is 2 cosine of 2x over cosine of x. And now when I plug 0 in there, cosine of 0 is 1, so I get negative 2 times 8, or sorry, negative 2 plus 8 over 1, which gives me a value of 6. Okay? So the other thing that we haven't dealt with yet is what happens with infinity. And so the same thing applies with infinity. So we'll do this, this in class, okay?